Hello, today we're going to talk about translation. So far we've talked about reflection and rotation and their transformations. A translation is also a transformation, and it adds to this like rigid motion, which means that nothing's changing size or dimension. Okay, and so we read this as, what is the simplest transformation that would map one of the following figures onto the other? And in truth, you can actually reflect these. So you could put the little tail, flip it around, and then flip it along a diagonal. And eventually you can actually get it to match up exactly through reflection. Rotations sort of similar, but you'd probably have to combine a couple different rotations together to make it work out. And so the key to this is that it says, what is the simplest transformation? And we have this new idea called a transformation or a translation. So here we go. What a translation does, and again, because transformation and translation both start with the same four letters, oftentimes kids get the vocabulary words mixed up, is essentially you just have to have a distance and direction. Okay, so an angle measure in degrees is really helpful. And then you have to have a distance. So when I do this, this looks like it was 4.5. If I were to go from a different spot, let's just say right where the point of the gray reaches the circle, and draw this line, and I translate it up there, what you'll notice is that the lines are parallel because they actually do have the same slope. They have the same angle to them, and the distance is still, again, 4.5 centimeters. Okay, so this kind of gives us the basics of what a translation does. We can come down and we can look at this, and it says draw at least 3 different vectors. Vectors, again, require distance and direction, and so I have this transparency to help us, and it really doesn't matter what corner. I'm just using the corners to help me be able to best keep things consistent. And so if I have this and this is my vector, it provides the distance, which is pretty much going directly to the right. And what I would do is just slide that right corner directly to the right. So it started here and it ends exactly at the tip of that arrow. And so this is what the transformation along that vector would look like. You can do that with any vector you want. So you could make the vector really angular, really long, really short. So if I keep this point at the top right hand corner, and I can slide it down until I get to that top right hand corner, and then I have this tip right at the corner, and you can see how it once looked and now it's translated, and now what the result looks like. Okay, so please take a moment, kind of give yourself an opportunity to summarize what a translation is, what a vector does for you, what are the requirements for a translation. Okay, example 2 kind of highlights some of the properties of the translation. And so we have lines, line segments, angles, and we'll talk about their properties. What we're given is you always have to start off with the vector. So this is your vector. It provides a direction based on like its array. So starting at H going down to I can tell that by where the arrow is. And it gives a distance, and if I were to measure this from the H to the I, that measure is 6.5 centimeters. Okay, so let's just focus then, go in alphabetical order, but A has to go down that same exact direction at that same distance. So if I slide this over, get my 0 on, and it lands just right at that point. So that is 6.5 centimeters. It's kind of nice. And so this is A prime. Notice that these two lines look very, very parallel. They would be if you were able to actually put a grid on there and figure out the slope. B would come down here, so here's B prime, and here's C prime. And what they really want you to understand is that since this is 31 degrees, the rigid motion would keep the exact angle measure. And here we are. This is also 31 degrees. So measure of angle A prime, B prime, C prime equals 31 degrees. Okay. And so that's a big takeaway. So I'd pause the video right now and I'd make sure that I understood that angles retain their measure. Next I look at D and E. Well, I noticed that this already has the prime. So where did it come from? So you kind of have to reverse the direction and reverse the distance, but I'll notice that the D, which is what gave me D prime, is right here. And E can come down at that same direction and distance, and this would give me actually E prime. And so I have 5 centimeters and I have 5 centimeters. And so what do I know? Line segments retain their length, and that's a really big deal. Finally, we have this lines, well, they go on forever, so our representation of the line needs the arrows, and what we should notice is that they ultimately are actually parallel as we go through them. So big takeaways, angles are kept. The distances for line segments are kept. Every single time I drew a vector from like the pre-image to the image, so pre-image to image, that distance was 6.5 centimeters, and it was the exact same direction as the vector that you were provided. Okay, reminder, we're going to be talking about parallel lines really soon. It says draw passing through point P that is parallel to L. There's a couple different ways. One way that we talked about is you draw a line and you essentially create the angle copy. And so what I need first is an arc. So I start and put my needle here. I have the arc. And then what I have to do is I start on the intersection, and then I make an arc down here. Start at the intersection, make an arc here, and then I connect the two. And that's the use of an angle copy to create parallel lines. There are a few other ways. If I were to actually do an arc, like consecutive arcs through point P, so I don't have my compass here, but if I were to take an arc and make exactly the circle that goes through point P downward, and then replicate that 3 different times, I could get a series of bubbles. And where those bubbles overlap, I can connect the dots and I can draw the parallel line also. And we'll go through one that's a little more similar to that tomorrow in class.